All right, so I won't spend too much time here. This is just a little bit about me. I've been in the game for almost 30 years, given many talks at a lot of the conferences. You may have other conferences you may have been to. Um, the main thing I want to point out here is, I'm very passionate about testing and quality assurance, obviously, because I've been doing it a long time. But I'm also equally passionate about giving back to the community. I'm involved. I'm a board member of 3 different nonprofits in the Atlanta area. One of those is the Software Quality Group. That is the largest user group in the Southeast. We have about 1,400 members. So I'm very passionate about that as well. My contact information here if you want to reach out. So why IoT? Why are we talking about IoT? What's different, right? We have a number of devices and applications that are disrupting the market and naturally disrupting our software development process, right? And we're here to talk about what makes it different, right? So I'm not going to cover that on this slide, but IoT does require a different approach. I found out the hard way, which we'll talk about on one of my big projects, my first IoT project that I got a chance to work on. And another thing that's important with IoT is starting with the right test environment. And we'll touch on that as well. The one thing, I spent a lot of time in the mid 2000s and beyond working on mobile applications when the first iPhone came out, right? We had the smartphone explosion. So I remember pulling my hair out working on setting up device labs and doing all those things. And as some of you know, I actually created a solution for that. I have 3 patents in the mobile technology space. So I'm very intimate with kind of that pioneering, edge when we have emerging technologies that present challenges for us in the testing space. So anyway, we'll touch on that a little bit as well in terms of the permutations and the variations. And the last one I think is the most interesting. So Gartner did a study. They published, I believe, in 2020. And they basically said that if you follow the same approach, the same test strategy that you did for mobile or for desktop applications or for anything else for that matter, and you apply that towards IoT, those projects will fail 89% of the time. Okay, pretty powerful. And by fail, we mean over budget, too many defects, product didn't meet the requirements. All of those things define failure. Okay, so that's the reason why we have a little bit of different approach. So that's why we're here to talk about IoT. But why are you here? I'm curious to know. What are you just curious about IoT? Is anyone working on IoT projects right now? One in the front over here. Does anyone have IoT on their radar, maybe, or their company is talking about it, or over here? Great, even more. That's awesome. So, anyone want to mention specifically in a specific purpose or something that you want to take away from this presentation? Anyone? No one? Okay. Just curious, huh? All right, so our agenda for today is we'll talk about first, what are we talking about? What is IoT? We'll kind of define it real briefly. I'll go over some quick market trends in the space, and then industry challenges. These are generic challenges, no matter what form, because you'll soon see, IoT is pretty vast. It's not just Alexa, right? There's so much to IoT in terms of an industry. And then we'll go over what I see as some of the top 5 testing challenges, along with solutions and how to address those. Now, again, keep in mind, the solutions are not silver bullets. I don't have magic potions or silver bullets for you today. Sorry. I have approaches, okay? Because this stuff is still fairly green space, and we're still trying to figure out a lot of this stuff. So there's no tool recommendations. It's more strategic in how you approach these things, okay? So keep that in mind. Any questions or comments? Okay. So let's start with, how do we define IoT? So obviously we're familiar with wearables and Nest, Amazon. We have smart cars now. We have smart TVs, right? All of these things, we're surrounded by IoT. And yeah, so we and really the other thing to point out is a mobile device, is it IoT or not? What do you think? We have an expert here in the front. It is. So for years, we have segregated mobile from IoT, but essentially, if you look at the definition, which I believe is on the next slide, yeah. So we have four things required to technically define what an IoT device is. We have to have a unique identity, okay? So we have to have an IP address, which is what we use to identify those devices to make them unique. And we have sensors. You can have just one sensor that qualifies for an IoT, right? Embedded electronics and a wireless communication. So wireless could be Bluetooth, Wi-Fi, right? Any of those things. Those four things. So does a mobile device have those four things? Yes. So technically a mobile device is an IoT device as well. So, and then of course, I put a little fun fact down there. One of the key constraints for IoT was, again, that uniqueness, being able to identify each device uniquely. And so IPv6 presents us with a multitude of IP addresses, and it says here 340 trillion addresses. So 100 times the number of atoms on the Earth. So we're not running out of those anytime soon. So good. We're good there. So what we typically start with IoT is we talk about sensors. And when I started digging into this, I had no idea. There are literally thousands of sensors. And I kind of broke down just a brief sampling of some of the categories. So a microphone is a sensor, right? We have vibration sensors. In automotive, we have oxygen, all these different things, radar, especially with a lot of the, like autopilot uses a lot of sensors, right, in the Tesla. So again, I'm not going to read through all of these, but just to give you a flavor of how vast, right? And can anyone tell me who can guess what the first sensor that was ever invented? Anyone?
Thermometer?
Yes. Do you know what year it was for bonus? 16. What year was the thermometer? I asked, what was the first sensor invented? And he said thermometer, which is correct, but what was the year? It was 1603 by Galileo.
Wi-Fi or Bluetooth?
So anyway, I thought that was cool. So sensors have been around a long time. And obviously, we continue to create and invent new sensors. So moving on to the wireless aspect, there are essentially two, there's more than two. We have Bluetooth Low Energy too, but there are two prominent protocols that we use for IoT. There's Zigbee, which has less manufacturers, but it's really good for short distances. You can add a lot more devices. And then there's Z-Wave, of course, which has much more support in terms of manufacturers behind it. And these numbers have changed too. These are a little dated. And those are better. Z-Wave is obviously better for longer distances. So that's pretty much it. I'm going to try to keep it light here from this component so we can get to the rest of it. Okay. So again, devices can talk to each other, or they can talk through a gateway device. And that's when we say talk to each other, that's the concept of mesh networking. It's very key concept to IoT. So you have devices that can piggyback off each other, right? They act as repeaters. So if you have a device, if you're trying to, let's say IoTify this room, and you're trying to create sensors maybe in the ceiling, you would maybe position them, 15, 20 feet apart. But the one sensor from here would talk to the one that's closest to its neighbor. Does that make sense? So it becomes like a mesh network. Okay, so essentially IoT can be anything that's connected. All right. There's, I don't know if you see anyone recognize the image in the middle there with the lady with the glasses? You know what that is? Yes, good catch. So we're surrounded by IoT, right? So it literally can be anything that's connected, as long as we meet the definition of those four items, right? We have a unique address, embedded electronics, wireless, and sensors. Okay. So real quick, want to cover some statistics on the state of the market. So total addressable market, hopefully everyone knows what that is. That's everything that can be attached to IoT. So just a few years ago, we doubled from 2016 when we first started measuring this metric from 150-ish to over almost 400 billion. And in just 2 short years, I think this is from Forbes, they're estimating we'll reach $6 trillion. So quite a hockey stick there, right, from where we're at today. GE predicts that the industrial Internet of Things, so industrial is, think of smart cities, right? We're measuring, we're monitoring maybe a high-rise building, right? Or we're monitoring oil pipeline from Alaska, right? We're measuring gallons, making sure nothing is leaking or breaking, those kind of things. That's industrial, and they're estimating that will be 60 trillion in the next 15 years. So big money, big money. And then the last component here is the growth of the number of devices, right? The whole reason why we need that IPv6 for the uniqueness. We're quickly approaching almost 80 billion devices on the planet. I mean, that's mind-blowing, right? I mean, that's what, 10 times the world population on Earth. So we have more devices than way more devices than people. So some of the key findings from this Forbes report, they interviewed C-levels from companies around the U.S. Actually, this might be a global study. I'm not sure, but they were predicting that IoT will boost corporate profits by 21% next year. And 2/3 of executives say IoT is important now in terms of investing. And we have more than 51% have significant IoT projects out there. Now, some of the top challenges when they were asked were around staffing and expertise, looking at ROI, those kind of things. And some of the top solutions that they were looking at were using external vendors like an Accenture or a Capgemini or someone like that, or using third-party platforms. Okay. So looking at across some of the applications for IoT and in terms of adoption, I kind of really like this slide because it shows, smart home, which is what we think about, consumer level stuff and wearables, but we really don't think about smart city, right? Unless you're actually working in that field or working in that space. Smart grid, again, we talked about industrial Internet of Things, connected cars, connected health, right? That's going to be a big one in the healthcare industry. Smart retail, which I have had the pleasure of working in, and smart farming. So pretty cool stuff. And this is just another slice of the previous slide. It kind of shows more by industry and what's driving some of those industries. So if you have, let's say, for example, let's look at fleet management at the bottom. So if you're doing fleet management, you're really interested in the red is the hottest. So if you follow your finger down there, you see transportation and logistics, of course, and retail and wholesale is really hot in terms of IoT investment, leveraging IoT for that industry and for that need. It just gives you a glance. Again, breezing through this a little quickly because again, this is a little longer presentation. So. Okay, so IoT movement. One thing that I did not realize until I started getting into it is really, the trend here. We were, if you look at where we've been, who in here has tested mainframes? Anyone? So we started in the 60s and 70s with mainframe, where everything was centralized, right? Everything was in one place. Then client server came along and we became distributed, right? All the processing power and decisions were on the PCs, right? From the 90s to the 2000s. Then along came the cloud, right? So everything became centralized again, back to the cloud, right? That's the more prominent, more recent one. But now where we're headed, 2020 and beyond, is edge intelligence. Does anyone understand? Everyone understand edge? What we mean by edge? Okay. No? Okay. So great. We're going to talk about it here. Next slide. So edge intelligence, essentially, we're moving back away from the cloud to more distributed intelligence, which means decision making and processing power. Okay. And this is huge this is really huge. I never understood how important and relevant this was for IoT. So edge computing is moving computing back to the edge, right? The edge of the network, to the device, to the Alexa device, to the smart car, to the sensors, okay? And so that it enables analytics and knowledge generation to occur at the source of the data where it's being created, right? Obviously, you're going to have limitations there on what you can do because those devices are not going to be you're not going to have a lot of processing power, maybe in a smart car, as you would in a AWS cloud, right? So again, the purpose of this is, what do you think the purpose of having processing power and decisions at the edge? Any guesses?
Execution.
Speed of execution. Okay. Close. I mean, that's relevant. Yeah.
Security.
Security. Yep. Yeah.
How about autonomy if something actually is not on the network?
Bingo. You got it. That's the most important one. I mean, all of those things are relevant, but the most important is is a device always connected? Can we always assume a device is going to have signal be connected? No. So that's yeah. So that's the most important thing, right? Is we want to be able to make decisions, right? Think about the situation with a smart car. If we have a Tesla that's driving down the road, an autopilot, and it's relying, let's say the Tesla is relying on the cloud to make that decision of ball rolling across the street, child chasing after it, apply brakes, right? If I have to rely on the cloud, what if I'm not connected and I can't make that decision, right? That's what we're talking about with the edge, right? We need to be able to make those decisions right there locally. Forget about cloud, right? So edge intelligence basically allows us to take action, to perform analytics, and take action on those things at the edge of the network. Make sense? All right. So key takeaways: distributed is back in style, baby. So processing power is shifting back to the devices, back out, just like we were doing with client server. And then large amounts of data are being collected at the edge, right? At these devices, and also being shared peer-to-peer. So cloud's not going away, right? We're still transmitting and sharing information with the cloud, but we're also sharing information peer-to-peer, right? Especially if we have devices in a mesh network setup. So, and again, as we mentioned, processing and decisions are key. Okay. So I love the self-driving car scenario. That's why I keep bringing it up. Automotive, by the way, the automotive industry is probably the most all in with IoT than any other industry in the US. So they're very well invested in IoT. So again, we have 4 components when we're talking about IoT and the edge. We have, again, with the self-driving car, we have to sense something. We have to sense things all around us, right? We talked about sensor is key. What's one of the key components of an IoT device is a sensor. So in a Tesla or any other car, you have your sensors. Again, I don't know the specifics of how much radar is used versus camera in a Tesla, but I'm using this generically, right? Not specific to Tesla, but just generically for a self-driving car. So we have to recognize, and in this example here, I use a stop sign. So we have to sense, we have to use a camera, we have to use radar, something to intelligently identify that a stop sign is approaching, right? So we have to, we have to analyze that. We have to identify that I am in fact looking at a stop sign, right? Not a billboard of a stop sign, not a picture of a stop sign, but an actual stop sign. And so I have to recognize that using some intelligence, right? And then I have to analyze, what am I going to do? What am I supposed to do, right? So there's some computing that happens. Do I hit the gas? Do I apply brakes? What in this situation, how am I programmed as a smart car? What are the actions that I'm supposed to perform? Maybe it's some additional analysis, right? It may not be binary, go or stop. And then I perform some kind of action, right? So that's the key, is I need to be able to perform that action without reliance on cloud. And then if, let's say I have a stop sign that is crooked, right? And maybe it's leaning, maybe somebody ran over it, or maybe it has holes in it. or it's rusting, it doesn't quite match exactly my library of trained data that I have on what a stop sign is. So in that case, I need to be able to identify those variations, those permutations somehow, right? And then those things are then rolled back up to what? The cloud, right? So that's where the machine learning happens to say, I've identified 5 permutations today across this geographic region. Let's dump those in the library. So the next time I won't have the computing decision is not stalling out or saying, I don't know what to do in this situation, right? Because we don't know what would happen in that situation. What would the car do if it didn't quite recognize it? That makes sense? Okay. All right. So basic key takeaways here for IoT and Edge. So the cloud will no longer handle those key processing and logic decisions, right? It will all be done at the edge. Very important. But as we mentioned, the cloud does not go away, right? We still have a lot of machine learning and things that are happening, maybe in batch, maybe if I'm offline, right? I'm going to take my learnings, and then when I do come online, I'm going to shoot those up to the network, to the cloud, so that other IoT devices can benefit from those learnings. Okay. Then, yeah, yes.
So if you laid out what IoT defined as, is there a model for this offline online approach that is established yet, or is that still being kind of figured out?
Well, yeah. So the question was around I want to make sure I understand, around the asynchronous nature of IoT being offline, online again.
Yes, I gather data. I need to see something, but I'm offline. So is there a standard way of how that's obtained for a series of time before, I can now share it and I can go back to someone's thing?
Those are being defined, actually. Yeah. So yeah, there's all kinds of ways that's being sliced and diced. There's no one standard to answer your question. Yeah, lots of different ways. And that creates more complexity, right? More challenges for us on the testing side, of course, indeed. And I found that out, again, the hard way on my first project. So good question. Thank you. So again, IoT will involve, the edge will evolve IoT to be more data centric, okay? And there's going to be more math and analysis done, more data science, right? And less coding, less programmatic. And actually new programming languages are already being developed for this stuff. So, all right. Moving on to industry challenges. So these are just generic things that we have in the industry. So, and I'm reminded of in the early days of mobile testing, again, when the iPhone first came out, and I was forced, to test this stuff with no tools, no reference point. We're kind of in that same boat, right? We're trying to figure out a lot of this stuff. This is greenfield space, right? So that's why there isn't a lot of expertise or things that you can really reference. It's tough. So what does that mean? It means let's focus more on the approach, on the strategy, right? Consulting with what limited information we have, and making sure we have a good test strategy in place. And another thing that we'll talk about is everyone familiar with risk management? So risk-based testing, right? So that comes into play a lot more with IoT. I found old concepts coming back again. So quick poll around the room, try to keep this interactive and fun, see if you're awake. What percentage of organizations do not have a specific test strategy, not I checked the box. No, like a detailed plan, right? For IoT. What do you think it is? How many, raise your hand if you think the answer is A, 26%, 36%, B, anyone? No takers? C, 59%, a handful of you, and then D, 79%, probably the rest of the room, right? Okay. So it actually used to be 79, but we're improving. We're at 59% is the answer. So 59% do not have a strategy. That is scary stuff, right? But again, it's a testament to the greenfield, the space. We're still trying to figure out a lot of this stuff. I really pondered on this one, and I came up with some potential reasons why 59% do not have a strategy. And I thought, a lot of folks are relying on device manufacturers. So think about if I'm assembling a self-driving car and I have some radar components and I have these sensors, right? Let's say I'm General Motors. I'm not manufacturing the sensors. I mean, in some cases I might be, but they're probably coming from Samsung or Sony for the cameras or the lenses. Somebody else is making those. So the company, in this case, General Motors, maybe relying too heavy on the component manufacturer's quality process. And that is a big no-no. And when you're doing this stuff, you need to do, ever heard of integration testing? So again, I think some of that is coming into play from what I've seen. There's a little bit too much reliance on, okay, well, I got this camera from Sony, so it's good, right? I can just plug it into my self-driving car and it's just going to work, right? No, yeah.
I got a good example of that. Recently, I bought a sensor for voltage measurement, and it turned out there were clones of this chip that were out on the market that had a different address. So the I2C technology couldn't talk to the device, even though it looked identical to the real thing.
That's a great example. Yeah. So, yeah, clone parts. I mean, who would think that somebody would do that? But one of the other reasons I thought was maybe people are relying on app services to do the third-party app services test process to do the validation. So it kind of ties into the previous one as well. And some executives are really comfortable taking those risks. They're like, well, we don't really know what we're doing. Let's just roll the dice, right? Very scary, right? Some, I think a lot just don't know where to start. And I think that's where a lot of folks, they really are just, maybe they're just using the same approach, right? And we already talked about where that gets you, according to Gartner. 89% of projects fail, right? So it's pretty scary. So again, this reminds me, I love the original Google beta there in the middle, and the Netscape Navigator, for those of you old enough to remember that. But the problems are very similar to where we were in the mid-2000s, right? When the iPhone came out. I make a lot of comparisons to that. The other thing, as I mentioned before, IoT expertise is scarce. So when they interviewed, wherever this study, I think it was Forbes, they said 82% have less than 3 years experience, 82% of people in this space. So again, it's very, very tough. We're kind of wild, wild west. So just to summarize some of the testing challenges, again, we're going to break these down a little deeper here in the coming slides. There's way too many platforms. We have hardware, software, security, again, is wide open, so many devices. We have so many protocols to deal with too. So this is like exponentially more difficult than anything that is in traditional software testing. We have data transmission, right? We'll talk about that. There's so many things. We're talking about connecting with the cloud, connecting with other devices, peer-to-peer. All of these things in the end will transform our QA lab, like our test environment, right? That's going to be really key to making sure we have a good setup for testing IoT, making sure we have good coverage, and so on. So let's see, moving on. I think we're good on time. Perfect. So anyone familiar with the Gartner hype cycle by chance? So the hype cycle basically talks about when a new technology comes out, right? Whatever it is, AI, right? Something that comes out. It starts out on the left side of the hype cycle, and as it moves up, it has various milestones. If you follow the bottom, you have the technology trigger, right? It's an idea. It's aha, I discovered something. And then as the marketing hype builds up, it reaches that peak of what we call the hype. This is why this is called the hype cycle, right? So as we reach the peak, the technology gets more and more interesting. There's lots of articles, there's lots of buzz, there's lots of high expectations, overinflated expectations, and then the technology is starts to come a little bit more mainstream. And as it does that, it reaches reality, right? Smack. And we start falling to reality. And that's the trough. We reach the trough of disillusionment. So the trough of disillusionment is where all that hype gets deflated, right? And we're like, okay, this is what this can really do, right? Not just what some guy in a review wrote about in an article. And then as a technology becomes more mainstream, it kind of flattens out to the maturity side of things. And these things can take decades to progress, like from an idea all the way until it becomes mainstream adopted, or it can take a month, right? It can happen super fast, or it can take 100 years. So there's no rhyme or reason to it. But the key to this, I used to track this a lot in the early days of mobile, is when you're talking to your managers, right? And let's say they're dropping, okay, guys, we're going to work on this new IoT thing. Well, I've never tested IoT before. You can point them to this IoT hype cycle to say, look, this is green space. This is not established territory. So you have to lower your expectations. When you're talking to your management, you can refer to them and say, look, this is still green space. So you can't expect us to have the same level of quality. We're going to have some bumps along the way. So that's the point of referring to this, is use this as a tool to kind of say, look, we're still trying to figure this out, and this space is just not mature enough. So realize that there's going to be problems, and we're going to need more investment, more training, more leaning on other resources, right? Because it's expertise is scarce. All right, time for another poll. So what percentage of IoT devices are currently vulnerable to security issues? Who thinks it's A, 27%? No takers. What about 48B, 48%? Couple of you, okay. C, 70%, half the room, and D, 88%, probably the other half. Okay. It used to be 88%. We're getting better. It's 70. So 70% of devices. And so this is testing challenge number one, is security, right? Some gentleman over here mentioned it earlier. Very, very important challenge. And the second largest DDoS, we all know what DDoS attacks are, where the internet goes, we have outages. So the second largest attack that actually caused an outage. So most people don't realize we have a lot of these DDoS attacks that happen that are blocked, that don't cause any outages, right? They're blocked, and they save the day, right? Everything's good. So, but when we do hear about them, the ones we hear about, of course, is when the internet goes down for I think it was over 12 hours in this case, in this use case. So those are the ones where we feel the pain. And this was caused by an IoT security flaw. So directly, point and center, took PayPal, Twitter, all kinds of big sites down for 12 plus hours that day. So again, this was the way a typical DDoS attack works. So the initial impact was 158 million, and they could not fully. They were still calculating like 3-4 years later after this happened, so they gave up. It was like well over $1 billion in indirect impact, right? You think about the 158 million is nothing. I mean, it's not nothing. It's a lot of money, but compared to the indirect economic impact downstream, it's immeasurable, right? So huge impact. All right, so solutions for this are basically leverage what you're doing today. In this case, specifically for security, you can use traditional approaches for this challenge. So again, if you're doing static testing, dynamic testing, pen testing, more importantly, I'm seeing a lot more folks, especially now with the Chat GPT explosion, leveraging AI to attack these challenges is becoming much more effective. But again, your code reviews, your pen testing, all of these techniques become much more critical, obviously, considering the potential impact of taking the internet down. They become vital. So we all need to do our share when we're doing security testing. Okay. The challenge number 2 is too many platforms. So when we say a platform, we're talking about Google, Alexa, right? That is considered a platform. We have, at last count, and pretty sure this number has grown since I put this slide up, is 122 platforms. So that makes it really tough to standardize on testing tools or an approach or something, right? There's so much fragmentation. It's really become exponential on the hardware side. And then, of course, software, we have the OS. We don't only have the operating system to deal with. We also have firmware on the devices themselves. And then, of course, we have an ecosystem of applications that are unique and specific to this. Makes it really tough. And it will give you a headache if you think about it and try to sit down and try to approach this. So one of the key things that I like to do, when we're talking about this, is first set your test objectives. What is it that we're trying to accomplish here? Is security number 1? Is wireless communication number 1? Again, focus on one component, because and obviously if you can structure it that way, have dedicated teams, right? Have a team that just focuses only on security testing for your IoT platform, and another one that maybe focuses on performance or functionality, right? Or wireless. And of course, set your scope properly with good testing types. Which ties into the previous one, right, with test objectives. Analytics, this is a tough one because this is such a new space. We don't have a lot of analytics. It's with web and mobile, we have tons and tons of data, right? We can go back and say, yes, 83% of our users are using Chrome with this extension, with this, right? You can kind of extract those and say, this is where we need to apply focus. With this, there's nothing. So what I have been talking about with a lot of companies is create your own, right? Start creating your own analytics, because we don't know how that's going to be leveraged in the future. So bake it into your design process, right? Start creating some type of analytic data that will benefit, even if it's just internal. At some point, it may become external, right? Use subsets. So this ties into what I mentioned earlier about risk-based testing. Very, very important here in this approach with your platforms, because when it gets so fragmented and exponential, it becomes very critical to use that to analyze, okay, this component is really high risk for security-wise, so you're going to apply more weighting to that approach, right? More resources, more time, whatever it is, to that. So that's what we mean by using subsets, because you just may run out of time and resources eventually, so you need to figure out how to apply those weightings properly. Another good one that I've seen is crowd testing. So this is nothing new, it's been around, but you can certainly leverage this depending on what your IoT solution is. CI/CD outsourcing and partners, so it's another one. There's a lot of the big guys and even some of the mid-tier guys. Again, we're talking about like the Accentures and people that do professional testing services. Bring them in, right? Maybe they have somebody who is an IoT coach like myself that can come in and coach you through that process and say, here's how to navigate these things so you don't make the same mistakes that others have. And then manufacturing conglomerate. So this is something new that I've never experienced. It's not new to me from a software perspective, is getting manufacturers like Philips and Sony, which are direct competitors, to actually collaborate together, right, to create standards. So some of that is happening to try to make this space less confusing, less platforms, right, less, more centralized standards and less fragmentation, which is going to be helpful to us. And then, of course, you can invent your own approach, which is kind of what I had to do on my project. So the third challenge is around data transmission. And so again, we talked about having vast amounts of data coming across that are being transmitted, right? Whether you're online, offline, whether you're doing it in real time or you're doing it in batches, we're talking about a huge amount, because think about all that's happening at the edge, right? At that smart car, at that smart street light, whatever it is. So we need to have devices that have good connectivity, low latency, right? That's not always the case. So some solutions are to use network virtualization. Has anyone ever done network virtualization testing where you're simulating kind of connecting to a cellular tower in a virtualized space? A couple of folks in the back. Yeah, so there was a solution back in the day called Shunra that did a lot of that. So, you can leverage those kind of concepts. So you can literally simulate, you can recreate, let's say I have 1,000 IoT devices that are connected in a mesh network, and I need to simulate what those look like connecting to an AT&T tower with 3 bars in Vancouver, right? Somewhere. I can literally simulate geographic by bars, by location, by anything. You can create your own, set up your own scenario. So those kind of things work pretty good. Obviously, performance monitoring tools, there's lots of those out there you should look at. So a common one that we found in the IoT space is memory leaks. They're slow. They don't happen quickly. So you run your test, let's say you run a load test, and then everything's fine. Everything worked great. But then you walk away, 15 minutes later, the device is crashing. Why? Because that memory leak was delayed, right? And it happened in a deferred moment. So those performance monitoring tools can help you identify those things, those issues. So the fourth one is too many protocols. Again, there's not much we can do here. There's so many there's 8 different communication layers, right? And I'm not going to dive into all of these because we're running out of time. But the key here is, again, you think about Wi-Fi, Bluetooth, Zigbee, Z-Wave. We talked about those. That's just only one layer. Okay, so we have a lot more layers and things that are happening, and some of the solutions around that I have found to work well is using middleware, using a lot of middleware tools like Postman and things like that, right? API testing, but you're not going to be able to use them right out of the box like that. You're going to have to do some customization. In some cases, like I had to do, I created my own I used my own tool to solve my problem because I couldn't find any tools out there that really did what I needed to. So you may have to do that, find a developer, create your own utility. So the last challenge is around the lab. That's the most important one. Obviously, you need to make sure you have high test integrity. So test integrity is making sure that your environment, all your sensors, all your pieces, your firmware, all your software is as close as possible to production-like so that you have a valid test environment, right? Who here has written up a defect and developer came back, environment issue, server issue, right? Everyone, right? If you've been doing testing for at least a year, that's come back at least, a quarter of the time, right? So very, very important here to make sure that you start off with a good, a good platform and a good, you validate your approach. Every time you kick off a series of tests, you have to do, we were talking yesterday about, device check, right? Sensor check. Before you even kick that test off, you have to be able to know, is there a heartbeat? Are you online? Do you have full battery? Do you have, because the battery's test, right? Invalid test. Can't write up a defect on that. Unless that is your actual test. If you're testing and doing a negative test, maybe. So again, you want to focus on test coverage. Very important. And I think we're running short on time, so I will move through this. So the biggest thing here that I found was, there's lots of solutions up here, right, for the lab. There's using virtualization tools or simulators, leveraging existing tools or creating hybrids. But the one that I found to be the most effective for my situation anyway, on the 2 projects I worked on, were using a test harness. So a test harness that you create, and that's where you literally sit down with the developer. Is everyone familiar with a test harness and the concept, what that is? Okay. So a test harness is basically another product. You have to create this utility that is going to interface with your device application under test. And in this case, your device is under test too. So there we go. So I call it advanced unit testing. So it's a collection of software test data, and so basically it's used a lot for partially built systems, right? Where you create stubs. This was my saving grace for some very large IoT projects that I worked on for a couple of Fortune 500 companies. For pretty big stuff, pretty exciting stuff. So we carved out 3 months to build this very sophisticated test harness, and that enabled us to slingshot through a lot of our testing process. So any questions on that? Here's some screenshots of some sample testing harnesses. And so, yeah, basically, that's all I have. To recap, make sure you have good test objectives, good test coverage. We talked about security. We talked about the importance of your test lab, right? Designing that, and really training and evolving, right? That's a really tough one because of the lack of expertise, but it does exist out there if you look for it. I'm one, so come find me if you need me. And of course, monitoring in governments, because this stuff does not sit still. It's going to keep moving as we move forward.